All right, so now that we're into additions, we do need to address the idea of stereochemistry. Everybody's favorite subject, stereochemistry. Okay, let's look at an alkene. Pretty simple alkene. And I will intentionally put a stereocenter. Here is a carbon which has it's sp3 hybridized and has 4 different substituents. That is a stereocenter, and it has that particular configuration. And so therefore we have a chiral molecule. Now let's treat this with HBr. We could write HCl, we could do HI, we could even do acid and water. That'd be fine. But let's just do HBr. What's going to happen is our alkene is going to be protonated by our strong acid. It's going to form a carbocation, and we'll go straight for the more stable of the 2 possible carbocations. In this case, it's going to be a secondary carbocation. We'll avoid that primary carbocation. And we'll have Br- as the counter ion. And so what's going to happen to our carbocation? Our carbocation will be attacked. And since this is a trigonal planar carbocation, and almost all our carbocations are, this bromide is going to be able to attack either from the top or the bottom face. It's a trigonal planar carbon. It has a top and a bottom, and the bromide can attack from the top and the bottom. As it turns out, since it's flat, we're going to get about a 50-50 mixture of this. So sometimes the bromide is going to attack from the top, and sometimes it's coming from the bottom. It's not super clearly shown, but that's what those 2 arrows are meant to show, from the top face or bottom face. And in fact, we will see 2 different products of these. The bromide comes in from the top. I'll go ahead and fill in the hydrogen to make it explicit. We'll get that product, and that's from top face attack. And if it comes in from the bottom, that hydrogen will instead be up. The bromide will be down. And then here is bottom face attack. What's the relationship of these 2 compounds? Well, these are stereoisomers. And if you notice, they have the identical stereocenters, except for the stereocenter on the right with the methyl group. That has the same stereochemistry, but we flipped the other one. So these are actually diastereomers. And we get them in about a 50-50 mix. And we would say there is no stereo control in this reaction. And why do we say there's no control? Because we get about a 50-50 statistical mixture. That reflects the fact we have no control of bringing in the bromide from the top or the bottom face. So that's what we see. Anytime you have carbocations, you tend to lose stereochemical control because these carbocations are flat and you get attacked from the top and the bottom face. That is not true for all addition reactions, just addition reactions that go through carbocations. So this video is about we're showing that there's no control, but we're setting up the fact that we will see stereo control in other reactions. But we just don't tend to see it in the reactions that go through carbocations.